is to notice that acetic acid and acetate are the same amount of moles. So that means that they're going to have the exact same concentrations. And so if we go ahead and solve out our concentrations for each of those, acetate would be 0.002 moles. Our total volume is 40 from acetic acid and 20 from sodium hydroxide. So 40 plus 20 is 0.06 liters, right? And that's going to be the exact same molarity as acetic acid because it's the same total volume and the same amount of moles. So when this happens, they're going to just divide out to 1, right? Because our Henderson-Hasselbalch equation, let's scooch this down a little bit, right? Oops. Is pH is equal to the pKa plus log of the concentration of acetate, or the conjugate, divided by the concentration of acetic acid, or the weak acid. And whenever those are equal to each other, this right here, that expression is just going to cancel out to 1. And if you plug in 1 to your calculator, the log of 1, sorry, into your calculator, is just 0. And so that means that we're just really focusing on this part right here. That's the only part we really care about. So pH is equal to pKa, because when those two concentrations are equal, they divide out to 1, and the log of 1 is 0. And so for our pH, it's just the negative log of K. So pH is equal to the negative log of our Ka, and our Ka is still 1.8 times 10 to the negative 5th. Squeeze that in there. And so if you take the negative log of our Ka from up above, we know that it should be 4.74. Right? And so that's our pH. So the important thing here is when we have, change my color to my highlighter to pink. Whenever acetic acid and acetate are equal to each other, then we know that pH is equal to pKa. And the important part here is called the halfway point. So whenever those two are equal to each other, that is the halfway point. And we can just take the negative log of Ka to find the pH. So it becomes a little bit easier. All right. The next part, we added 30 milliliters of sodium hydroxide. So go ahead, pause it, same steps as before, and then I will solve it out. So moles of acetic acid, 0.04 liters times 0.1 molarity, 0.004 moles. Moles of hydroxide, we added 30 milliliters this time, so 0.03 liters. Concentration is still from up above, it's 0.1 molarity, and so we end up with 0.003 moles. All right, next step, set up our ice table. So we have same equation, acetic acid, hydroxide, acetic acid, and water. We're going to plug in our moles, so we need to make sure we divide by total amount of liters at the end to get back to concentrations. And so we have 0.004 moles of acetic acid, 0.003 moles of hydroxide, cross out water, 0 initially of acetate. All right, the one that is smaller is the one that gets subtracted to the left side. And so 0.003 is smaller. And so we're going to subtract that to both of those and add it to the right hand side because products are being made, not destroyed. And so acetate would be 0.003 moles. Hydroxide is still our limiting reactant because it's canceling out, it's 0, and our acetic acid is 0.001 moles. All right, our next step is to find our concentrations of each of those. And so our concentration of acetate, we'll start with that, is 0.003 moles. We need to divide it by the total amount of liters. We added 30 milliliters of sodium hydroxide, and we had 40 milliliters of acetic acid, so 40 plus 30 is 70 milliliters. And I'm going to go ahead and convert that to liters just to make my life easy. And so 0.003 divided by 0.07 is going to end up with 4.3 times 10 to the negative 2 molarity. I'm going to scooch this down a little bit. See if I can fit everything in here. And then for acetic acid, HC2, H3O2, we have 0.001 moles divided by our total liters, which is 70 milliliters, or 0.07 liters. And when you divide those two, you end up with 1.4 times 10 to the negative 2 molarity. All right, next step is to plug it into our Henderson-Hasselbalch equation. So our pH is equal to the negative log of the Ka, that's our pKa, so 1.8 times 10 to the negative 5th, plus the log of acetate divided by acetic acid, so the conjugate divided by the weak acid. And so our conjugate is 4.3 times 10 to the negative 2. I'm getting that from right here. And our acetic acid is 1.4 times 10 to the negative 2. Simplify that into your calculator, and you should end up with a pH of 5.22. All right, we're almost there. So the last two, there's 40 milliliters, and then there's 60 milliliters, and then we're going to sketch the graph. All right, so 40 milliliters, we are going to start off the same exact way. So we're going to start off with the moles, ice table, and then see where it goes from there. All right, so our moles of acetic acid, same as before, 0.004. Whoops. 0.04 liters, my bad, sorry. So 40 milliliters converted to liters, 0.1 molarity, which ends up with 0.004 moles. There we go. Our moles of hydroxide is going to be very similar because we have the same amount of volume, 40 milliliters, and our concentration is also 0.1, so we have 0.004 moles. All right. Let's set up our ice table. I'm going to try to put it up here on the side just because I know I write big. I'm trying to save a little bit of room right now. Right, so we're plugging in our moles. And so we have 0.004 and 0.004 for both of the reactants. We don't have any acetate yet. Because both of these are the same, we are going to subtract that same amount from both of them. Because neither one is smaller, so that is the number that you subtract. And then you add it to the other side. So acetate is 0.004 moles, and then acetic acid and hydroxide are 0. All right, so the important part here is whenever the reactants are equal to 0, that means both of them are used up. That means that there's no acetic acid and no hydroxide left. That is called that's going to create an additional step. And so we need to create a second ice table in order to solve this. Woo, ice tables. All right, so we're going to start with acetate and H2O because that's what we do have, right? We have acetate in the solution. And so I'm going to create a second ice table by setting it up. We have acetate, which is C2H3O2-, and we have water. One of these hydrogens is going to donate over to the acetate and become HA, so HC2H3O2, right? So acetic acid. And then it will also create hydroxide. All right, so this time when we set up our ice table, we just flipped the equation basically. And the reason why was because we need to make sure that we have something to actually calculate with. That's the end point. So whenever you don't have any of the reactants left, you're at the end. All right, and so let's go ahead and let's use molarity for this ice table. So we're going to use molarity instead of moles, just to make our lives a little bit easier. And so our molarity of acetate is the moles divided by the total liters. So we have 0.004 moles. And our total liters is 40 plus 40. And so that's going to be 0.08 liters. And so when you divide that in your calculator, you should end up with 0.05 molarity. So I'm going to plug that in for the initial. Water is a liquid, we can ignore it. And we have 0 acetic acid and we have 0 hydroxide. All right, we're going to do minus x plus x plus x. This is 0.05 minus x, x, x. All right, the next step is to set up our K equation, so products over reactants. For this one, it's going to be a KB equation because of the hydroxide right there. And so because of hydroxide, we have KB is equal to acetic acid and hydroxide on the top. Those are our products, divided by acetate on the bottom. We don't have KB, but we do have Ka, so we can do a little quick step over here. Kw is equal to Ka times Kb. We know that Kw is 1 times 10 to the negative 14. Ka was given to us up above, 1.8 times 10 to the negative 5th. Divide to both sides to find our Kb, and we can plug that back in to our equation. So our Kb should end up being 5.6 times 10 to the negative 5th. Sorry, 10 to the negative 10. My bad. And then on the top, the products, x and x. On the bottom, we have 0.05 minus x, but because x is so tiny, it's negligible, so we can ignore it on the bottom. So we can just plug in 0.05 to make our lives easy. Cross multiply and then square root, and we end up with x equaling 5.3 times 10 to the negative 6. All right. We know that x is also hydroxide, right? So we know that x is hydroxide right here. And so we can take the negative log of that to find our POH. And once we found our POH, we can go ahead and subtract 14 from that to find our pH. So I'll do this in bright pink. Right, so POH is the negative log of our x, and our x, remember, is 5.3 times 10 to the negative 6th. So our POH equals approximately 9.2, 8.72. So it's going to be 14 minus the pH. Sorry, I got distracted with my calculator. So when you take the negative log of the x, which is 5.3 times 10 to the negative 6, you get the POH. And 14 minus that number should give you 8.72. Alrighty. And our last one before we have to graph it is going to be this one right here. So we add 60 milliliters at this point. And 60 milliliters added to that, we're just going to do a simple ice table and then the Ka. So let's go ahead and do this. We have the moles of acetic acid, 40 milliliters, or 0.04 liters times 0.1 molarity, 0.004 moles. The moles of hydroxide, 0.06 liters, 0.1 molarity, so 0.006 moles. All right, and then we have acetic acid plus hydroxide. That's our equation we've been using this whole time. Acetate and water. We have our ice table. All right, let's plug in our moles. We have 0.004, 0.006, 0, ignore water. All right, we're going to subtract 0.004 because that's the smaller of those two numbers. And then add it to the right-hand side.